You know the feeling, right? You see a system that looks absolutely perfect on paper, a work of art, but then it's a total nightmare in production. Well, today we're going to dive into exactly why that happens. We're exploring something called the clean architecture abstraction trap, and oh boy, the hidden costs of following the rules just a little too perfectly.
I mean, this quote just hits the nail on the head, doesn't it? It gets to this really painful paradox that so many of us have faced. You do everything by the book, you've got your perfect layers, your strict dependency rules, and somehow the system just groans and creaks the second it's under any real pressure. So let's unpack this. How can the correct solution actually be the wrong one? And this is exactly what we're calling the abstraction trap. It's that moment when a really good idea, like clean architecture, crosses a line. It stops being this helpful guiding principle and turns into a performance-killing, productivity-sucking bottleneck. All right, so how on earth does something that looks so correct on a whiteboard go so wrong in the real world? Let's get into the symptoms of what this looks like, this architecturally correct failure. And I bet these symptoms are going to sound painfully familiar. Your traffic spikes and boom, latency just shoots through the roof. A tiny little feature request comes in and suddenly you're touching 5, 6, 7 different files across all these layers. And the best part, when you try to debug something, the stack trace is this ridiculously long, confusing staircase of indirection. Here's the kicker. Production doesn't give you bonus points for pretty diagrams. It punishes, and I mean punishes, unnecessary complexity. And this really gets to the core of the whole problem. The runtime, the CPU, the garbage collector, they don't care about your beautifully separated layers. They have no idea. They just see the work you're making them do. And every single one of those abstract layers, that's more work. And that work has a very, very real cost. Okay, but let's be fair here. We didn't end up here by accident. These patterns didn't just appear out of nowhere. To really get why we crave something like clean architecture so much, we got to take a quick look back at what things used to be like. So if you remember the 2000s, a lot of big enterprise systems were, well, a mess. You had this tangled spaghetti of business logic all mixed up with frameworks. It was a nightmare to test and just terrifying to change. Then, in the 2010s, clean architecture shows up and it felt like a breath of fresh air, a promise of discipline, of order. The only problem? Over time, those amazing principles started to fossilize into these rigid cookie-cutter templates that people just applied everywhere, without even thinking if it was the right tool for the job. And I mean, the promises were so compelling. Come on, who wouldn't want this? The idea that you could be totally independent of your framework, that you could test your precious business logic in complete isolation, you could even swap out your entire database if you wanted to. It was this promise of architectural safety, and man, was it attractive. But there's always a but, isn't there? That feeling of safety comes with a price, and it's a price we often don't even notice we're paying until everything's on fire in production. Think of it like a hidden abstraction tax. Okay, let's make this concrete. Just look at this typical request flow. For one simple thing to happen, your data has to jump through all these hoops. It goes from the controller to the use case, through an interface, to the repository, then the ORM, and finally gets mapped to a DTO, all before you can even think about sending a response back. That is a lot of steps for what should be a simple operation. And at every single one of those hops, you're paying a little toll. You're transforming data from one shape to another. You're creating new objects. You're adding another link to the promise chain. Now, one of these little operations, no big deal. But add them all up and you get this constant memory churn. You're creating and throwing away objects so fast that the garbage collector is working overtime and the runtime just can't find good opportunities to optimize your code.
Let me give you a real-world example. We looked at a system under heavy load. The actual database query, the part that's doing the real work, took only 12 milliseconds. That is blazing fast.
But get this, the total response time for that same request, closer to 90 milliseconds. The vast majority of that time wasn't the database, it was just the overhead of passing data between all those internal layers, mapping objects, and waiting on promises. That, my friends, is the abstraction tax, clear as day, right there in your metrics. So how do we get out of this trap? Well, it takes a fundamental shift in our mindset. We have to stop thinking about what looks pretty on a diagram and start focusing on what actually performs well at runtime. It's really about starting to think like a senior engineer. You can really boil it down to two different mindsets. On one side, you've got the diagram-friendly approach. This is all about conceptual purity, following the rules to the letter. But on the other side, you've got the operationally efficient mindset.
This is about optimizing for what actually matters in production. How fast are your critical hot paths? How easy is it to observe and debug the system? And how fast can you actually ship changes?
Oh, I absolutely love this quote. Piling on abstractions for some problem you might have one day in the distant future, that's not engineering discipline. It's architectural insurance without risk modeling. It's like buying the most expensive flood insurance policy when you live on a mountain. You're paying this constant daily tax and complexity for a benefit you will probably never, ever need.
So, the solution isn't to throw all rules out the window. It's to shift our thinking. We need to move away from blindly following a set of rules and start actively measuring the cost of our decisions. It's time to measure, not just speculate.
And this table gives us a really practical way to think about it. Look, does clean architecture make sense sometimes? Absolutely. If you have a huge team working on a really complex, evolving domain, that strict separation can be a total lifesaver. But is it over-engineering when you're a small team owning a pretty stable, CRUD-heavy service that needs to be fast? Yeah, it almost certainly is. The key takeaway here is that architecture is all about context. There's no one-size-fits-all. So when you boil it all down, what actually matters? First, the clarity of your hot paths, the code that runs all the time. You want to minimize all that indirection in your latency-sensitive code. And you should be adding abstraction based on measurement, not just guessing ahead of time. Let the architecture emerge from the real constraints of your system. Don't try to impose it from day one.
So here's the question I want you to take back to your own code base. The next time you look at an interface, a repository, any boundary layer, ask yourself this: is this boundary protecting me from a real, likely source of change, or is it just duplicating complexity, adding another file I have to edit, and another hop in the call stack?
And that really brings us to the final, most important point. Real engineering maturity isn't about memorizing patterns from a book and applying them perfectly. It's about deeply understanding the trade-offs. It's about measuring the costs of your decisions. And ultimately, it's about having the wisdom and the confidence to know when the simplest solution is actually the best one. It's about knowing when it's time to break the rules